need.
From FastMCP, import FastMCP, client. Import OS. MCP equals FastMCP, test server. At MCP, tool. Def greet name, SDR. Prefix equals OS environ get, greeting prefix. Hello. Return F prefix, name. Client equals client, MCP. Async with client. Result equals await client, call tool, greet. Name, world.
This demonstrates the in-memory transport pattern for FastMCP, where client and server operate within the same Python process. The approach creates a direct, zero-overhead communication channel by bypassing both subprocess management and network layers. What distinguishes this pattern is its ability to maintain full environment and state sharing while eliminating transport latency. The pattern works by treating the FastMCP server instance as a local dependency that the client can instantiate and interact with directly. This design leverages Python's native async context management to handle connection lifecycles, while the shared memory space enables immediate data passing without serialization overhead. The declarative tool registration via decorators remains identical to distributed setups, preserving code consistency across deployment scenarios. This approach matters most in testing and development environments where isolation requirements are minimal, but performance and simplicity are critical. It eliminates the complexity of managing separate processes or network connections, allowing you to focus on tool logic rather than transport mechanics. The trade-off is reduced isolation. For production or scenarios requiring strict process boundaries, you'd switch to SDDIO or HTTP transports while keeping the same tool definitions. Let's break it down.
From FastMCP, import FastMCP, client. Import OS.
Imports FastMCP for creating AI-callable tools and client for server communication. The OS module handles environment variables, used here to configure the greeting prefix dynamically.
MCP equals FastMCP, test server.
This initializes the FastMCP server instance named test server. It's the central orchestrator that registers tools, manages connections, and routes AI requests to your Python functions. Without this, no tools can be exposed or called.
At MCP, tool. Def greet name, SDR. Prefix equals OS environ get, greeting prefix. Hello. Return F prefix, name.
This is a FastMCP tool definition. The @MCP tool decorator exposes the greet function to AI models, using type hints to generate the schema. The environment variable fallback, OSEnvironGet, makes the greeting prefix configurable without code changes.
Client equals client, MCP.
This instantiates the FastMCP client, the entry point for all tool invocations. The client handles serialization, network transport, and response parsing, abstracting the RPC layer so you only work with native Python types.
Async with client. Result equals await client, call tool, greet. Name, world.
This uses an async context manager to handle the client connection lifecycle. The async with block ensures proper connection cleanup after the tool call completes, preventing resource leaks. Inside the block, call tool invokes the registered greet function with the provided arguments. FastMCP client initialization. The async client initialization pattern bridges Python code and MCP servers, enabling seamless tool execution while handling connection lifecycle automatically. Manual initialization with auto-initialize equals false requires explicit timeout handling to avoid silent hangs. This pattern ensures reliable server interactions whether using default or custom configurations.
The client that never connects is already connected.